Hello, I'm Gavin Halliday, SVP and Head of Platform Development, and I welcome all of you to the 11th Annual HPC Systems Community Summit. I would especially like to extend a warm welcome to everyone from our wider community, both business and academia, across the globe. We have a great week ahead of us, filled with informative talks and technical breakout sessions. So thank you for joining us, and please plan to interact and engage with our speakers throughout the sessions. Be sure to take advantage of this opportunity to hear about the innovative ways the platform is being used across the industry, academia, and in our own company. To start us off, it's my pleasure to introduce our keynote speaker, Mike Stefanik. Mike is the Managing Director at EY, a recognized leader in the field of AI, machine learning, and open AI platforms. Mike's expertise involves driving innovation and strategy across various industries, including risk, legal, banking, insurance, healthcare, and government. With over 20 years of experience in analytics and cognitive computing, he has a proven track record of leading digital transformation and delivering tangible results for clients and stakeholders. We are honored to have him present today on a topic that impacts each one of us: how AI will disrupt work and allow workers to thrive. So, with no further ado, over to you, Mike.
Thank you for that great introduction, Gavin. Really appreciate it. I'm also excited to be here today to give this keynote. Just a little on my background to share with you where I'm coming from and my experience. So currently I'm a managing director at EY. I run our America's risk platforms that are powered by AI, and that's across every single sector. Little more background, was the Senior Vice President of Analytics at Equifax. So one of the big significant things the team did there is we introduced machine learning into ensemble models for credit. Was a partner at IBM, drove some of the initial Watson AI financial services opportunities. And then before that, I was a global head and director at SAS, the high performance computing platform. I do also want to highlight founding board member at Kennesaw State with my good friend, Bill Franks, who I think did this talk last year. So if you really like the talk, thank you. If you don't like it, then you can have a conversation with Bill. Any event, let me move on. So diving right into the material. So the interesting thing is, right, as we think about machine learning, and this slide I first did at a keynote back in 2018. Machine learning's been prevalent in about everything we do on a daily basis. You may not notice it, but it's there. So from price optimization, inventory optimization, mobile offers, a lot of retail content, in addition to navigation, GPS, voice recordings, right? Automated service, engine efficiency. I'll let you read the list. This has all been in place really in earnest since 2015, maybe even a little bit earlier. But the interesting thing is, as we think about this, a lot of this is still very much focused on very specific points that are driven by data and a very targeted outcome, right? When we're talking about customer service, what it'll do is it'll prompt and fill in order, potentially, more to your liking. Beyond that, navigation, right? It's going to take you to your destination. On traffic management, it'll give you a very specific task. And a lot of this, if you look at the bottom, has been driven for technology that's really been around for 50 years, but really starting in 2018 with the advent of some of the open AI, Gen AI models, we're now seeing an uptick in this. The interesting thing, right, as we go through this, is that we have been moving really in three continuums over time. One is very, very much automation driven by rules, human designed outcomes, right? Really with machine automated processes. Been around since the days of, accounting system automation. Beyond that, then what really happened in 2009, 2019, as I touched on before, data became the driver with human designed outcomes, but augmented by machine-trained narrow data sets that were highly curated, that really allowed for those targeted outcomes that I referenced in the beginning in the last slide. Now we're on the horizon of human-described scenarios, but machine-tuned models and machine-managed data. Now we're gonna open this up, take a bigger look, explore this more as we go through the talk. But the interesting part of that is that we're really automating out the handcrafted models and the highly curated data. And that's good news. We do need to monitor, as you notice at the bottom, for human monitoring for confidence and trust, right? But the really key part of this thing is that we are reducing the time to tune our models, and we're reducing the amount of highly managed curated data. And what that's going to do is it's going to return back time for us to really thrive in this application of AI by allowing humans a broader set of decision scenarios and a broader set of potential that they can explore over time, while also learning and monitoring. So we just step back and think about this for a minute. We're moving from highly structured to sampled to really scenarios that become highly interactive in the dialogue. And that's going to cause a change, right? A change in the way that we think about applying the technology. So let's step back for a minute, right? Because I do want to dive a little deeper on how to apply this in the human decision framework. Because if we don't start here, this really won't allow us to think a little bit more about how we can thrive across this context. So if we think in general about the way we make decisions today, whether we're buying a car, we're buying a house, we're making a decision on an investment project at work, right? We're in the process of building a new architecture, right? The first thing we're going to do is we're going to step into it and establish a context. From that, then, we're going to create an evaluation process. What are the options? What are the scenarios that are needed? That'll then drive itself to, okay, let's think about the alternatives. Today, in the human context of doing this without automation, right, we will take our time to generate alternatives. We'll collaborate with others. We'll bring past reference data points into the perspective. But pretty much we're going to generate scenarios and we're going to apply prior knowledge. This will be continually informed by expert training that we've had over time, experience, the console of other, but we get to a very informed judgment and a decision, and we may or may not record it, right? I don't think anybody is really going to debate that much. What really changed then, when we think about the first round of kind of 1.0 in augmented human decision with machine learning, is still going through that process of creating scenarios, creating a context. But the first big leap for us was in applying trained data through known prediction alternatives, applying knowledge, trained very much for the machine learning and more narrow context that I talked about earlier. We'll still rely on past judgment, still very much a strong human in the loop concept for this, informed by training and expertise, but now we're starting to trade off some of that prediction alternatives and scenarios with what the machines are bringing for us over time and applying that knowledge. This again still relies, nets in informed judgment and then a decision, but with the advent of 2.0, large language models and the rest of the decision frameworks, we're now starting to see that we can really create this contextual, data-driven, real-time interaction that, quite honestly, doesn't need to have an end, right? It can be a continuous learning process, not so much designed at one goal, but designed to expand a certain domain of knowledge. So if you look at the difference in this diagram versus what I presented earlier, still creating scenarios, but what we're doing is we're extending the context, bringing in multiple, if needed, domain-led data sets that are really focused on this real-time interaction and constant learning. No longer are we reaching in, curating data sets, thinking about, is that the right data for the scenario? But at this point, we're still bringing forward some of that knowledge. So we'll be applying the knowledge, bringing forward past judgments, and then it's going to be informed by the training experience. What this is all going to do is create a continuous learning context, which is really going to be key in terms of the way we look at this augmented judgment and working with humans. That really is the model that is getting a lot of adoption in the market today, because what we're doing is we're integrating human in the loop along with this training exercise that's very interactive and is not as much a disjoint process of let's create a scenario, let's go mine the data, let's train a model, and let's bring it forward. That's really going to increase our adoption, really going to start to build trust in AI, LLM based models, and really start to bring the user and the human in the loop into the discussion. Now, in order to move forward with this, can't stress this enough. If there's one thing that you walk away from this presentation with, it's really about context. Not so much about the model types anymore, the technology we use. Certainly, and we'll talk about the data and the data domains that we're applying in context, but context is king, right? So it's very much like, to give an example, when you're starting, maybe a project at work, or even let's say you're going to, decide to build a house, right? The large context, which sits off on the right of this, is okay, where, what location, what's the best option. The guided context would be in the middle, what the builder is saying, okay, here's the blueprint, here's the plan, here's the step-by-step process in this. With the small context on the far left being, these could be the actual selections for the home, right? Maybe the appliances, maybe that. But using those metaphors, it's really important then to start to think about the context. So let's dive deep. We're going to start on the left-hand side of the slide and go in, right? So one of the classic techniques that's emerging now is a RAG-based LLM, retrieval augmented generated model. And really the strength in this is applying that augmented context. Now, what's really working here is the fact that we are taking the time to define the context for the decisions that we would like made out of that. But what we're not doing is narrowing that data set all the way down to the individual elements, but we're being clear about what that is. So let me shift this to a business context, and we'll explore some of these a little bit later. But this could be a legal context, could be an HR context, could be risk, could be marketing, right? Could be subdomains within marketing, right? But the weakness in this is not being clearly defined around what that context is for a knowledge domain. The other thing around this is, and I'll talk about this across everything we discussed today, is as you build this and add that knowledge into those model types, we really need to consider that this is not a one-time content update, but a very active content update. So that as the knowledge that you've started to bring in this, whether it's documentation at this point, whether it's spreadsheets, right, whether it's other maybe text-based presentations that you're considering, not only is this sitting in a content management system, but you're also applying APIs to that so that you have a continuous stream of data and understanding that'll come in. And I'll show us an architecture in a bit around that. The next one on the guided context is, and I'll have a demo on this a little bit later, is really thinking through the chain of thought prompting, right? This is a middle ground, right? And these can be augmented, these can be used with augmented LLMs, but as we think about putting together a guided context, so if we are in that legal context and we have a legal document review, and we want to be in the process of not only reviewing that document, but perhaps we're offering a service that has a guided summary and that it cites very specific sections within that document, we want to make that a consistent process for our user, right? So whether it's the chain of thought prompting or, and we'll talk a little bit later on embeddings, we have the ability then to guide our user through a discussion. It's really going to have a clear human in the loop interaction. And from that, again, we're always updating our content from an API perspective. The last on this, which you're probably most familiar with, and where a lot of the buzz has been over the last few, really 18 months, 24 months, has been large language models. The benefit here is that you're bringing a very large context, a context also that's very general. There's reduced training time on that, right? You put a lot more unstructured data, text, other interpretation to it. The challenge with that is they're very expensive to train. So really, when you pull context together, the key parts of this is the fact that you want to take the time to curate the context, then the information that you're augmenting. Recommend you start on the small context, but then also think about the service that you're offering out to either your company, right, or your users, that you have a guided context associated with that. Nothing wrong with large context models, but they're very general, right? And they are going to actually inhibit the adoption. If you go back to that high interactive scenario that I described earlier, that we're all looking to drive and adopt over time. So let me let that sink in for a minute, and I'm going to translate to where we are today. Because one of the big challenges is, especially on large language models, is that we're running out of data. We're running out of public data, believe it or not. There's been a number of studies out there. This one's from MIT, and as a part of that, what we're finding is a lot of the general knowledge is already being consumed, and some of this you'll find, as you actually use models yourself, right? You're going to find that they are very general. This is where they do tend to hallucinate. This is where, not using the techniques before, you're going to find very general answers. And it's really, at some level, unfair, not appropriate to use a large language context, but really start to focus on more of the private data that's available for training. And so from some studies, less than 3% of private data, has really been used for training, right? So the key thing here is to bring value and to bring ROI, is really to take a look at the data that you have within your organization. Think about it from two avenues. One is there's a lot of unlocked value in that data that could be brought forward. And not that you're going to share it publicly, but the structuring of that, putting together these knowledge bases that I'm referring to, are really going to propel that forward. The other side of the equation is that in using both the small context and the guided context, that's where this is going to apply. So as we start to bring these data sets together, it's going to be key that when you think through it, start to organize it by domain, augment it with the large public data. But this is really what's going to propel the industry. So let me move forward on this next one, man. So this takes me to one of the key points that we've been focused on a lot, in terms of some of the businesses that I've been working with, and this is across any domain. Could be financial services, could be insurance, could be healthcare, could be a number of different areas. That knowledge layer, and I'll expand that out, is really key. Now, how do we prepare a knowledge layer? What that's really going to be aligned to is ontologies and graphs. So this is where, now you may be saying to me, well, Mike, wait a minute. That's not all that different than really having to train models in draft. But what it's doing is you're elevating it and reaching a little bit higher in the structure, if you would, and putting together a complete structure that would organize the data and then also associate relationships across that. That's my reference to the graph. So for those of you that aren't familiar with the technology, I realize there's a technology audience. You are going to be using, potentially graph technology to join different relationships, establish relationships across that. And this is a technique that we found very successful in order to bring this together. Having these ontologies and graphs set up and associating them with that knowledge layer really creates a structure for the domain, so that we can plug it in as a structured knowledge layer. Again, if you think back to where I was earlier in the conversation, this was really the opportunity to bring together that prior decision knowledge, right? new information, APIs bringing that data together and putting a structure to it. The other two sides of this thing then become, we have a clear application layer. So this is the interaction piece. So whether it's a chatbot, a guided workflow, structured prompts, whatever technique we end up using, this is the part that's going to guide us through that knowledge layer and then really give us that focus on being able to create significant potential to not only reduce our dependency on some of the COTS applications that we may have, our commercial off the shelf, but it's really going to give us the opportunity to organize our information, HR, legal, CRM, or risk, right? It'll also at the same time give us the advantage of augmenting core capabilities within the IT side. Later on in this, I'll actually show us a demo that'll talk about how, or actually show us how we can augment business analyst behavior, right? And start to generate use cases and other specifics. The other structure then, just to round this out at the bottom, is the large language models as a service. I know there's a lot of focus on curating large language models and being able to tie data sets into those. We talked about the RAG models, but at some point, what we're really going to evolve to is LLMs as a service, because they're going to continue to evolve. Large language models as a service will continue to evolve. They'll become more sharper in the way that they can respond. The response times will get better, but they'll still need to pull out of the left-hand side of this graph, meaning going back to the ontologies and the graphs and being able to pull that layer together. This entire ecosystem that I'm talking about here is really what's going to allow us to create that conversational layer that I mentioned earlier. This becomes the continuous learning capture, the ability for us to continually update data and then pull this in as a service. I'm not saying that today that you may be focused on LLMs, but with most of what we see across the industry right now, it's a lot of proof of concept views that aren't really transitioning themselves into production and really into that continuous learning. And this is a way to approach that. Now, what you may ask me, and let me go a little bit deeper here. So give me some definitions, Mike, around this. So as we look at this in the knowledge layer, it's really clear definitions of what that domain category is. So I want to stress here too, this not only is requirement knowledge, but it's very much strong domain knowledge in the way that a marketing person would think, a legal person would think, HR, risk and compliance. So as you think about crafting that knowledge layer and putting those teams together, you should be bringing a very much a mixed team together to help curate this and be able to pull that together. It will net in requirements, but it's also going to feed very much the ontologies in the bottom part. The other part of this is, which I mentioned, the definition should be at the document shared subject area level. We're seeing, and there is reuse in data lakes and some of those techniques. We are seeing an overdependence in time on being able to over-curate the data. What we want to do is really structure this into documents, knowledge bases, be able to link across those. And again, really bring in that concept of having clear marketing review, domain review, clear legal domain review, HR, to constantly curate and make sure that at the document and knowledge base level is set versus doing it at the kind of database level. The other side of this then on the ontologies and graphs is depending on the complexity of that graph database, you're going to need to really be clear about how these relationships come together. So within the marketing domain, for example, right, the context of customer, product, service level, fulfillment, inventory will all have to be defined very clearly and then joined across that database so that when we're then applying these into some of the vector databases, right, that are really the backbone of translating knowledge within large language models, this will be established and then well-defined. Again, all this should be fed and utilized via an API so that you're being able to update this on a continuous basis inside of that ecosystem that I just described. Okay, folks, we're about halfway through. I hope you're still hanging with me here. Let me bring it together within this kind of human and AI context then. So really to pull all of this together, we need the input from the highly creative human. Again, back to what I said on marketing, HR, and the rest. Make it collaborative. We're going to be testing for ethical content, ethical outputs, are they truthful outputs in a world that it may not be fully defined and what those outputs are. But we will still start to define that context very heavily. What the AI is going to bring for us is automated analysis, right? It's going to be able to go do the embedded research, right? It's going to be continuously updated, and it'll bring together both of that broad and narrow context. So on the right, what we end up with is this kind of must-haves, right? So just to really summarize here, a dialogue-based interface, human in the loop, right? Knowledge layers that I just talked about in the last two slides, connecting in with vector databases, API feeds for continuous updates and what we're doing. And then really those embedded prompts to sharpen our queries are really the must-haves for this context decision. So hopefully before I go into some more specific examples, we're painting the picture. As you really go from the 1.0 into the 2.0, this is what I'm anchoring for on the right-hand side. Now, let me move forward a little bit. I'm going to show this technical diagram, technical description as to how all this comes together. Always get the question, okay, the slides are interesting, but how do we pull this together? So if we look over on the left-hand side and you take a look at the knowledge base, again, you'll see reference to documents and databases that come in. These form data pipelines, right? And so you'll see some, sample technologies there, right? Whether it's Databricks or Airflow or some of those technologies, they're going to be the basis for your data pipelines. From that, then it'll really be flowing into a processing layer of a vector database into a vector store, where we'll chunk that information, we'll index it, and then we're going to put it into either Pinecone or Mongo or one of these commercial vector stores that allow us to structure that, and then it flows into the application layer on the right-hand side. And again, this may be a little different than what you've been doing in some of the POCs, but the model in front of us is really an emerging model in the industry, and it cuts across multiple sectors, right? You've seen this play out in financial services, seen it play out in insurance, but it's been a reliable framework to start to structure the information and put it over to what really needs to happen on an app hosting layer. So what you'll see within it are the key elements in terms of that application that I referred to earlier. Workflow engine, standard UI UX. Maybe you do want to go with the chat engine prompt and make it very dialogue oriented. That's fine. That all works because you can create agents that'll fulfill within that. But what they'll rely upon is a standard set of generative LLMs at the bottom that generate the response that are pulling from that knowledge base over on the left. And again, there may be some classic machine learning augmented into that because you do need a very narrow response of going through that, and that's fine. And you see that off to the right. At the bottom of this, what you'll see here very, very quickly is the ontology layer put together. Schemas, documents, right, knowledge graphs, fulfilling into this LLM as a service is going to be key. But as you see the mapping of this, then just to really summarize this, knowledge base layers on the left, consistent data pipelines that are fed over time by APIs that feed a document store that's really continuously updating itself. On the right-hand side, what you'll see is consistency in the application and the way you're accessing the information, right? Whether it's a workflow engine, chat engine, those pieces, but that gets tied together with generative LLMs that are really a service in this, and then as needed, some orchestration across it. So I'm going to pause here in the depth. I'm sure there's going to be a lot of questions in the chat. More than happy to dive a little deeper on this. You may have a variant of this. This is fine, but this is generally where we see the industry and the architecture moving. Now, what are some high ROI use cases for this, right? Especially on Gen AI. I mentioned a few of these. Let me just take some time to walk through this. On the legal side, document summary, document classification are absolutely key. You may be doing some of that today. The other part of this, which is emerging in the industry, is the ability to track authoring of documents and the validation associated with it. Are you the original author, right? Is this, is there potential for plagiarism here? Or do you want to use it for tracking? That's really what, this is a really strong emerging use case in the industry. The other part of this is then, as you go a little further, is document content parsing, the ability to break that down. Is this legal context applicable to a case? Is there a case law that needs to be applied to a certain scenario? Is it a regulation? Does it need to get broken down? And then how would that land itself within a policy? All of these are high value ROI cases that are coming up. And then let's shift our focus over to risk at this point. Very much, and you're going to see a pattern emerge here. The risk summary and the risk use cases associated with this are very much the same in terms of a document summary, meaning that if I've taken maybe a legal document and I've turned it into a risk summary and a risk obligation, then Gen AI has been using across multiple industries, healthcare, insurance, financial services, even manufacturing, to summarize that and then create what the obligation or the role is in that second line. We're also seeing within risk, Gen AI used to highlight risk rating analysis and use cases in that lane. That's one of the emerging areas. So what would typically be done perhaps on a spreadsheet or on a survey basis still may be a survey out to a business unit to determine what its risks are. But prior, that would be summed up in a database or maybe even a spreadsheet. Now we see Gen AI coming into play and being used to actually perform some of those rating analysis techniques, and then augmented in some cases as a benchmark for external threat monitoring. In these two, we see a lot of potential because the combination of these two are really not necessarily replacing the human, but augmenting the human and supplementing the analysis that's done in what's typically a very labor-oriented process as we would go through that. The last two areas here that I'll kind of round out and we'll move to CRM are, once we've summarized the risk, found an obligation, put a rating to it, well, we got to control it. So that's what a risk control completeness analysis is, and Gen AI is being used very closely in that. So that starts to bring together, are these risks clearly mitigated? Are there controls wrapped around it? And it does that match the narrative that was identified in the risk summary. And then lastly, risk analysis and validation. So something to bring it all together that would tell us that we've gone, from the start in the risk summary, we've got the rating analysis and the completeness. Now, let me just take a quick sip of water and I'm going to jump over to the CRM. As a part of that, then, when we think about customer relationship management, the key thing is really customer response management. A lot of what we're seeing right now, and in one of the high volume operational cases, is to not only provide personalization in the space, but also really creating what some are starting to call the preference twin, the digital twin. Lots of terms for it. But you're leveraging customer response management to respond in the context that the questions that I ask, a similar answer. This will retain that customer experience over time and create an interaction history summary, that's both transparent to the buyer, but also allows for really one-to-one interaction in that customer relationship management space, along with retaining my preferences, right? Do I like to buy things that are yellow, right? Do I avoid things that are red, right? All different kinds of preferences that are out there can be summarized, time of day, those kind of things, which would lead into very much an automated product prediction. These are fast adopters in the retail side. We're doing a fair amount of work outside of the risk side in this area of product prediction within some of the retail activities at EY, and it's really starting to take hold. This all turns itself into a tailored product analysis, getting back to that interaction history and summary and preference summary, and then tying it together, as I mentioned at the very beginning, on what a preference twin would be. So again, you're not really mimicking me, but you're learning my preferences and anticipating my responses out to my one-to-one interaction. Okay, let me round that out here. Last set of high-value use cases. In the IT side, lots of initial use cases right out of the box that provided high value. Business analyst assistant. Really can't stress this one enough. I'll show you an example a little bit later that's literally going to take, from what would take 2 to 3 days down to about 15 minutes, because we're augmenting a typical business analyst case, and we're allowing the prompt guided high dialogue interaction method to really help us do the functions. So what are the use cases, right? What format do we want? Is this ready to send off into the next stage of the process? Also, then it lends itself to QA analyst, right? Which you'd probably natively think would match this. And then also lean into test casing and control generators, right? These three, I can't stress enough. If you're not using them today, these are really the low-hanging fruit around it, from Gen AI. The last three, these incident narrative summary, response ticket automation, and threat monitoring, all go into the cyber world. One of the really interesting use cases, and not that we didn't anticipate it, but it did kind of appear on us, was the fact that being able to really, with the volume of high cyber incidents that are happening, with clients today around the world, being able to very quickly summarize what that incident was, then putting together a response ticket that can be fed off to a remediation platform, an alert platform, right, a monitoring human platform, so that you're bringing in threat metrics to this at the right level is very key. So these three in conjunction have had a very large response, and are something that you should be thinking about a lot in terms of what you're looking for high ROI use cases. So again, sure, it's going to drive a lot of questions, and ask for more details, please, in the Q&A section of that, please ask the questions, we'll respond through it. But these are really kind of the low-hanging fruit pieces. Now, let me step forward into the demos that I've been talking about. Before I start this demo, I do want to highlight, so this use case is really at the guided prompt use case. Within EY, our brand is built really around regulatory and risk response. One of the questions that our clients came to us very often was the ability to take a very complex risk management process. So as a regulation would come out, how do I decompose that regulation? How do I create the obligations or rules that my business has to apply? How do I then map that out to an applicable assessment unit or a business unit, which you'll see in step 2 of this demo, which really requires us to respond. So if you're a large bank or any large financial institution, you may have a fair lending regulation that comes out that's going to apply not only to the retail side of your business, but maybe to the business side, your B2B lending organization. Right, so that typically takes weeks and months to work through. We'll show you in this example how it can map itself automatically to an assessment unit, and then go back and look for some of those control statements that I did highlight back in the examples earlier. So let me start this demo, and I'll show you actually how this comes together. So in the start of it, and again, because this we typically deal with a lot of lawyers, and they like to upload the document. What you're seeing in this case is the actual document. Now, this is a healthcare example. This is the No Surprise Billing Act. So what this means is, for any patient that's out there, what I have to do is actually give you a very reliable estimate not only to the customer, but also have to supply that back to the payer or provider. And it needs to be very much in alignment with the benefits that I signed up as a participant. So what you just saw was the machine reading that, summarizing that, bringing in an obligation summary. And then what we've allowed the machine to do is suggest what it is, and that's the confidence level that you see on the right. Now you can go through, and you just saw me tick these off as to, yes, these are some I agree with, this is the human in the loop, these are some I don't agree with, but that's fine, right? Because what I'm going to do then is accept that, create a set of draft obligations. I'm going to pull one up right here. So I've got the regulation. This is the obligation text. This means this is the rule or the law that I've got to follow. And within that, I've used the machine to create a summary. Now we're using LLMs to create that summary. And I'm using very much this approve reject. And as you can see, what the machine has done is it's actually taken a guess and showed a confidence level against what that assessment unit is. Is it a revenue department cycle? Is it a registration department? But these are where the laws and the applicability would happen. I can accept that and then move to the last part and say, and ask the machine to take a guess at taking those obligations. And again, here's the obligation summary text. And then mapping that against a control description that's out there. So in this case, there's some controls, right, within an Epic system. Epic, if you're not familiar with it, is tied to billing for a lot of these firms. And also the actual patient populations. So it pulls it together and it shows that, yes, these two have a high confidence. I agree with it. I'll accept it. Some of these I'll reject. And again, I'm just doing this for example purposes here. But I can approve this section and then move on, right? And this is really, in a lot of cases, a combination here of narrow LLM context, right? My very first example, along with a guided prompt, and joining these two together. So that's the demo in this case. And I know we moved through it. Again, please follow up with questions in that one. The next one I'll bring together is an IT business case. So in this case, what I've done is, and again, some of you will be very familiar with this. This is actually within OpenAI, and it's one of their chat GPTs, if you would recall. So the nice thing about it is, for demonstration purposes, you can augment documents that I talked about earlier. So what I did is I went out and I took a bunch of fraud documentation, really to use case level, based on some historical analysis that was done that'll show which one of these have high return rates, high IORs. But my end game here in this is that I really want to get this into a structured format so I can start a dialogue with some of my business users and really get their input to see if this makes sense. So in this process, it would normally take anywhere from 3 to 4 days, maybe, to go do the research, load the documents, have somebody analyze this on a spreadsheet, bring it together in this fraud use case. And what I'm going to show you here, let me just now turn the machine on. I've actually asked this LLM, this will be the small context model, to list the top fraud use cases by percent ROI, and then return that for her. So what it's doing now is it's taking that knowledge base I fed it, it's feeding in some of the higher cases. You can read them yourself here. Some of them are, synthetic fraud. Some of it is duplication and overlap, right? Some is compare, contextual information. Some of it's prior transactions. What's the ROI? Kind of like this that came in. Gave me the high ones, right? There are lower ones, but again, I asked it for high. So the next question I'm going to ask it for is, please provide the top features that would be associated for these kind of high ROI use cases, and format these in a specific format. Now, by now, you're probably figuring out I can talk faster than I can type. So you'll see that in the bottom of the demo here. And for those of you that are familiar with it, I've asked it for a Gherkin format, which is a structured format, so that you can see, as a user, those kind of things. It'll pop an example up here in a second. And then put acceptance criteria with it. So what the machine's now doing is going in and actually generating these, right? So here's the feature, here's the scenarios with it, here's the acceptance criteria. And those of you that focus in the business analyst world will say, wow, that's really quick. not meant to replace the analyst. What it's meant to do is really accelerate what the analyst would typically do over time and really get the dialogue moving, right? So that we're having actually, more of that validation exercise and the rest. So there are the two examples. Again, lots of information here today. I'm going to move now to close this. So I hope you really do found this informative. I know I gave a lot of information here, varying levels of detail. Please do reach out for questions. Excited to see where you all go on your journey on this. And let me just turn it back at this point. Thank you very much.
Thank you, Mike. That certainly gives us some food for thought. Some great architectural suggestions and plenty of use cases for each of us to go away and think about. We have about 10 minutes left in this session, so I thought I would use it to give you a taste of what the HPCC platform team has been up to. Last year, I may have naively thought that we had solved all our cloud migration problems, but this year plenty of issues have appeared out of the woodwork to keep us busy. Let's take a quick look at a few of the challenges we have faced and the improvements that they have inspired. We'll start with Thor. This year, Risk Solutions migrated all of our Thor environments from the Boca data center to the cloud. That's an amazing milestone achieved through the hard work of many people. There were teething problems along the way, which were fixed one by one, but once everything went live, there was still one significant issue: cost. The monthly bills were many thousands of dollars higher than we had expected. Ouch. That obviously needed addressing quickly. Otherwise, I would be having a very uncomfortable conversation with VJ. But what can we do? Well, one of the reasons it was costly was that we were using expensive virtual machines with large local NVMe disks. Why? Well, Thor spills datasets to disk between subgraphs, and when it cannot hold all the rows it needs in memory. And some Thor jobs require a lot of temporary disk space, so we needed the expensive virtual machines. Surely those some jobs required less disk space, so they could use cheaper instances. But which ones? Our first problem was that the platform didn't provide enough information to answer that question. It only reported information about some spills, and critically, there was no way of tracking the peak local disk usage. So we needed to fix that first. All activities and subgraphs now report details of their temporary file usage in the work unit. The example on the slide shows some statistics per subgraph. They now include the peak local disk usage for that subgraph and the running maximum for all subgraphs within the current graph. At least we now have the information we need to start answering that question. And I should mention that it's not just file usage that has gained some more statistics. Extra details are provided for joins, distributes, and other activities, all aimed at helping the developer understand what is going on with their jobs, spotting anomalies, and helping them to improve performance and reduce costs. We also took the opportunity to improve the way information is presented in ECL Watch. The metrics and graph display especially has had an overhaul. Kunal's talk later in the week will walk you through many of the details, including the question you may have been asking yourself, why some of those labels on the previous slides were bright red. The cost optimizer now runs on failed work units, and the recommendations are more prominent. Another change aimed at drawing developers' attention to areas of the jobs that could be improved or highlighting problems with the system health. So, now we have the information we needed, we could take a closer look at the long-running Thor jobs, especially those that used a lot of disk space. But for some jobs, the numbers still didn't make sense. For instance, a subgraph that read 4 terabytes of data was using 50 terabytes of spill space. What was going on? Where was that extra data coming from? Turns out there were multiple causes. Some of the activities were not compressing temporary files. And since compression often reduces file sizes by a factor of 5 to 10, that at least explained some of the strange numbers we had seen. As well as using extra disk space, not compressing files was also slowing the jobs down, because it's often faster to compress and then write to disk, rather than writing the uncompressed data. So the platform needed fixing. For some cases, enabling compression was as simple as setting a flag. Other cases required a more substantial rewrite. Subgraphs contain chains of activities. If you examine each activity in isolation, it often makes sense that it might need to spill. For instance, if it is reading ahead data from a slow activity. However, when activities are used in combination, there's often no benefit to more than one of them spilling. Improving the coordination between activities allows Thor to optimize when and where those spills occurred, which further reduces the temporary disk space needed. Taken together, these changes made a big difference, but there were still some strange outliers. After some head scratching, we spotted that some jobs contained pound options, which had been added to the ECL as temporary workarounds, often many years before. Unfortunately, they also had the side effect of disabling compression for the various spills. If anything, this is a lesson on the danger of temporary fixes. Once those options were removed, those jobs looked much better. What were the results? Now, unfortunately, I don't have a graph from before we started on any of the changes, which would have been even more impressive. But here's a graph of spill file usage from the start of August. You can see the big drop-off in peaks on the right-hand side of the graph after a platform update on the 7th. In fact, now, rather than most jobs using the expensive virtual machines, almost all our Thor jobs can now run on cheaper machines, potentially saving millions of dollars a year. We examined the Thor jobs to understand spill sizes, but in the process we discovered several other potential savings. What did we find? One subgraph contained a project applying regular expressions to fields in a dataset. It ran for over 5 hours, using more than 24 hours of CPU time. Surely that could be improved. The good news is it can. In version 9.8, Dan has made some significant speed improvements to the regular expressions. We haven't rerun that job with the new version yet, but I expect it to be at least 10 times faster, saving time and money each time it's run. Some subgraphs append files from many sources into one dataset, like this example. When we looked at the timings for the funnel, it showed more overhead than we expected, so we took steps to improve the implementation. Other examples showed some curious gaps in the timings between some subgraphs, like the screenshot on the slide. As with the spills, it turned out there were several different underlying causes. While each improvement like this may only save a few seconds per subgraph, applied to many jobs, they can quickly add up. And finally, the code generator was sometimes generating poor code when one side of a join condition turned out to be a constant. In one example, it meant a join that should have taken seconds was taking many hours. Needless to say, that has now been fixed. One interesting question is, why hadn't these issues with spills and slow subgraphs been spotted before? I don't really know the answer, but they all serve as examples where the focus on reducing cloud costs is also significantly improving performance. Note, if you're running on a bare metal system, then you're also going to benefit from these recent changes. So, cost was a big challenge for Thor. How about Roxy? Here, I think the biggest challenge has been diagnosing slow queries. They tend to be infrequent, intermittent, and don't follow a clear pattern. But however infrequent they are, you can be sure that customers will notice. Our challenge is working out the cause. Network, DNS, CPU, disk speed, thread contention, or slow external service. Now, traces have emerged as a key tool in understanding where time is being spent within a distributed service. allowing you to quickly visualize the end-to-end execution of a query. They're being adopted across our business units. So over the last year, we have added native support for OpenTelemetry traces to Roxy and the other HPCC components. There are two key aspects. First of all, Roxy preserves trace and span information that's supplied in query requests and passes that information onto any services it calls. That prevents Roxy becoming a black box. You can see details of the external services it is calling. Second aspect is for Roxy to create spans for important steps within the query. For instance, each query, graph, and SOAP call. These spans are exported to an OpenTelemetry collector, so they can be viewed in combination with traces from other services. Why not catch Mark and Rodrigo's talk later in the week for an in-depth look? We also continue to extend the information that Roxy publishes. As well as being logged on the complete line, this information is now recorded in the different spans to make it easier to diagnose the cause of any delay. I should also highlight that over the last year we have fixed several long-standing intermittent causes of slow queries, some of which have been there from when we originally went open source, more than 10 years ago. One final challenge of running environments on the cloud is that encryption in transit is required everywhere. That can add new complications and extra overhead. Here are a few examples. Server and client certificates expire, so they need to be periodically rotated. How do you do that while Roxy is running without impacting performance? You don't want to check for updates at the point of use, because that might introduce a delay. Instead, the system needs to periodically check them in the background to ensure they're up to date. And the handshake involved in negotiating a new SSL connection can add a significant time overhead, especially when the target is remote. Persistent connections can help spread the cost over multiple calls, but not all services will support them. So now you can independently configure the persistent connection settings for each SOAP call in a query. The TARDIS team have done a brilliant job of stress testing the secure connections, particularly when they're using the row service to read large amounts of data from different environments. That's led to a major improvement in the way the platform implements secure sockets. And finally, what of the future? Here are 3 areas we've been working on to ensure that HPCC continues to stay relevant and cost-effective. Most cloud providers are rolling out virtual machines using ARM CPUs, which are significantly cheaper than their x86 equivalents. So we've updated the platform to ensure we can take advantage of those systems. Parquet files. The goal here is to improve interoperability between the HPCC ecosystem and other external tools. Our goal is that they will be as easy to use as CSV, XML, or standard Tor files. Please catch Jack's presentation later to find out more. And of course, I can't finish without mentioning generative AI. If you watch Kunal's talk later, you'll see one way we are using it within the VS Code ECL extension to improve developer productivity. So, those are a few of the challenges we've faced and how we've dealt with them. Please take a look at the program for the rest of the week. Some of the talks explore these themes in more detail, and there's something for everyone. And a big thank you again to Mike for his keynote, and thank you to all of you for attending. Please enjoy the remaining breakout sessions, and if you can, be sure to participate in the workshops. And please mark your calendar to attend the awards ceremony on Friday to catch the announcement of the 2024 poster competition winners and community recognition recipients. Thank you and have a great day.